when you are trying to solve a problem, a triangle, in which you're given two sides and an angle, or two angles and a side, or something of that nature, three things are missing. The first thing you should look at is, can I use the law of sines? Okay, because this is a pretty easy formula to remember. You'll need to. Okay, you have either one of two forms. You've got sines on top or sines on bottom. Okay, but it's going to look like one of these two things. And you can choose which form of it to solve the problem as it is convenient for you. The first thing you should look at, though, is, do you have a matching pair? In other words, an angle and a side which are on opposite sides of the triangle. So a matching pair, for example, would be big A and little a. And you can see why that would be good in an equation, because if you have a matching pair plus, say, the angle B, you could use that to solve for little b. Okay, that would help you start unraveling this triangle. So let's go into this particular example and see what we got. So I see, let's clear this up here. I see, okay, big angle B, big angle A, and little side C. And if you look at that, there's no matching pair. So you might be about to give up hope and say, oh no, I can't use law of sines. But actually, there is one more thing we can do here. I was given two angles. So I can just say, well, A plus B plus C is 180 degrees, right? We learned that way before we learned law of sines. So you can solve for B, and I'll let you work through the algebra on that one, but it comes out to be about 23 degrees. Okay, so that's my big angle B. And now I know a matching pair, right? I know, well, let's see, what do I know? I'm sorry, I said B, but I meant C. Big angle C equals 23 degrees. So now I know a matching pair of big C and little c. So I'm going to pick another side to solve for, because that's all that's left, little a and little b. And I'm going to choose this formula right here, okay, because it's convenient. It has the things I want on the top of the fraction. So let's start this off this way. I'm going to solve for little a by saying a over sine a equals, we'll choose c, because I know that already, c over sine c. Okay, which I'm going to rewrite a little more into this form. A equals little c times sine of a. See how I multiplied both sides by sine a? That's going to help me solve this thing. And now I just plug in numbers. So that's going to be 4.31 times the sine of 57 degrees divided by the sine of 23 degrees. Okay, so we get from that a equals, let's see, what do I get here? 9.2510. Okay, now you won't need to have so many decimals as this. I'm just using it out of caution. When I'm in the middle of a math problem and I start rounding decimals, that's where errors come from, those rounding errors. They start small, but they tend to get bigger and bigger as you use the rounded numbers more and more. So I don't round my numbers until the end of the problem, or at least I don't significantly round them. I use a lot of digits. Let's move on and do little b now. Little b over sine b equals, same thing as before. Let's just pick on c. You could have picked a here. Shouldn't say the letter a while I'm writing. You could have picked a over sine a, because I know both of those. I'm just picking c because we already did that one. So b equals c times sine of the angle b divided by sine of the angle c. So what does that turn out to? It's going to be 4.31 times the sine of b was 100 degrees, okay, divided by the sine of 23 degrees. Okay, so from that we get little b equals 11.8630. All right, and there we go. Problem is solved. So you can see how the algebra works. That's not too bad. The trick, I think, to solving triangles at the very beginning is knowing which law you should apply. Law of sines, law of cosines, and sometimes law of sines gets a little complicated. We'll get into those cases later, but when you see two angles, that's a dead giveaway. It's definitely law of sines.